Generative AI uses the power of deep learning and reinforcement learning. These techniques enable generative AI systems to learn from large data sets and to improve their performance through trial and error. First, let's look at an example of how deep learning in generative AI works. Deep learning generative AI techniques have been developed for restoring old photos that have been damaged. The deep learning algorithms are used to analyze the colors, shapes, and patterns in the old photos, then use that information from the analysis to create a new, more aesthetically pleasing version. To achieve this, these models learn by first analyzing and learning the patterns of undamaged photos. Once the patterns are learned, the photos are artificially damaged by removing parts. The models are then used to fill in the damaged or removed parts based on the patterns they learned from the undamaged photos. The restored image is compared to the original and updates are made, improving the model's performance every time. The more training data the models are given, the better they become at restoring damaged photos in a way that closely resembles the originals. The powerful system behind that image restoration is a deep learning algorithm called Generative Adversarial Network, or GAN. GANs consist of two neural networks, a generator and a discriminator. The generator produces synthetic sample images, and the discriminator judges the synthetic samples against the real ones. They train adversarially. The generator tries to fool the discriminator, while the discriminator avoids being fooled. These images were generated by a GAN from NVIDIA that used an architecture called convolutional neural networks, or CNN. CNNs were originally developed for computer vision, systems for computers to recognize or classify images, and they are now being applied to GANs as well. In this setup, both the generator and discriminator start off with a layer of low resolution, 4x4 pixels. As the training of the model progresses, more layers are added to both CNNs, and this gradually increases the resolution of the generated images. These are some examples of what the final generated images look like with a 1024 by 1024 pixel resolution. Now, let's look at how the application of reinforcement learning has made modern generative AI so effective. On its own, a model can identify whether the generated image resembles the training data along a multitude of dimensions. But the model can't really see the image the way a human can. Here we have prompted the image generation model Midjourney with the text, "Portrait of Grandpa with Hands Folded." The V2 version of the model gave us this result. Those don't look like hands, do they? And you might also notice something weird happening with his eyes and the top of his head. Meanwhile, Midjourney B5.2 model gave us this. That looks a lot closer to an actual person, even if the textures are still a bit strange in places. Humans noticing issues like these and feeding them back into the model is a huge reason for the improvements you can see here. This is what reinforcement learning with human feedback, or RLHF, is all about. In the context of generative AI, reinforcement learning means model generates image and you have some mechanism representing the environment, and the model improves as these two components communicate back and forth. In order to capture those small details that only humans recognize much more easily than a model can, we add a human to the loop and try to optimize for the human feedback as well. Reinforcement learning without human input allows the agent or the model to discover strategies on its own using its intrinsic reward system. Reinforcement learning with human feedback provides an additional heuristic that speeds up or optimizes the agent's learning and ensures that the output meets human standards. To recap, both generative AI and discriminative AI are systems designed to imitate human intelligence. Discriminative AI uses machine learning and deep learning algorithms to make classifications or predictions and is evaluated based on whether the predictions was correct or not. For example, how accurate was my model at correctly predicting whether the patient would develop coronary heart disease or not? Generative AI systems draw on the techniques and architectures of discriminative AI, adapting the techniques and adding to the architecture for achieving a different objective. Generative AI are able to generate novel and creative outcomes that resemble the training data. While certain components can be evaluated automatically, human input is frequently necessary to enhance the accuracy and effectiveness of these generative AI models.